Hi, welcome to Dr. Raz, the Baking Chemist. So today's question is a Year 1 organic chemistry question. It's a 12-mark multi-part question with lots of different aspects of chemistry involved. Okay, so let's see what we can do. So G, a sample of monochlorooctane is obtained from a comet. The chlorine in the monochlorooctane contains the isotope chlorine 35 and chlorine 37 in the ratio 1.5 to 1.0. Calculate the MR of this monochlor. Right. Initially, when I'm looking at this question, I'm thinking, and this is what I thought a sample of monochlorooctane is obtained. The chlorine in the monochlorooctane contains the isotope. I thought the same molecule contains the Cl35 and the Cl37. But then I read the question again, as you're supposed to. A sample of monochlorooctane. So in other words, it's like I've taken a sample of chlorine gas. Yeah. Now that sample will contain Cl35. So one molecule might contain Cl35. And Cl35. The other molecule might contain Cl37, or another molecule might contain 35 and 37. Do you see what I'm saying? So a sample means they've got more than one molecules. So what they're saying here is, what you got to understand is that one molecule will contain 35, Cl35, and the other one will contain 37, and then you got to find out the relative atomic mass. Okay? So if I have a monochlorooctane, so I'm going to have a monochlorooctane. The monochlorooctane, I'm not going to draw the skeletal formula or anything. I'm just going to work out the molecular formula. So C8H. Now, it's not 18, okay? It's obviously because one of them hydrogens will be substituted for chlorine, right? So it'll be C17. And let's assume that the first one, so this one, is Cl35 in this molecule. Okay? I've got to work out the MR of this. So the MR of this is literally, you work it out 8 times whatever, yeah? So let's just work that out. So that is 148. Okay, and then you're going to have another molecule of monochlorooctane, which has C8H17, and this time the chlorine bonded to it is 37 isotope. And of course, that MR equals 150. And so now what you do, so you've got the MR of each of the isotopes, and now what you've got to do is you've been told what ratio they exist in. So now you've got to work out relative molecular mass. Yeah, calculate the MR of this monochlorooctane. And for this, you need to go back to remember when you're doing mass spectrometry and you were given peaks of different isotopes and you had to work out the RAM? That's how you do this. Okay, and so if you remember, the formula was, in this case it'll be MR, right? But I'm going to use relative atomic mass or relative molecular mass equals percentage abundance. If you remember the formula, percentage abundance of isotope 1 times by the MR of isotope 1. And then you add it to the percentage abundance of isotope 2 times by MR of 2. And so on, yeah, if there were more. And of course, you divide it by the total abundance. Yeah, in this case, they're giving you the abundance in ratios, 1.5 and 1.0. So what you do is you add them together, right? You get 2.5, so you've got to divide it by 2.5. And so you literally put the values in, okay? So percentage abundance is 100. Let's assume this is isotope 1, this is isotope 2. Percentage abundance of this is going to be, isotope 1 is Cl35, which is 1.5, so it would be 1.5. 1.5 times by MR of that, so which is now 148, plus abundance of isotope 2, let's assume that's that, so that's 1.0 times by 150 and then divided by 2.5, and that should give you 148.8. Okay, so that's 2 marks. Yeah, they do need you to work out, either use that equation, yeah, that equation, right, to get a working out mark and then the final answer mark, or use that. Okay, and you do need to work both of these masses out, because remember, you'll be putting these in there anyway. Yeah, so do that and that to work out the MRs of both isotopes, or use this calculation and you'll be able to get the marks because you put the MRs here, okay, for each of the isotope. Okay, let's move on. Isooctane reacts with an excess of chlorine to form a mixture of chlorinated compounds. One of these compounds contains 24% carbon and 2.56% hydrogen by mass. Calculate the molecular formula of this compound. So calculate the molecular formula. This is taking you back to the empirical formula that you've done at GCSE. Okay, so it's a basic basic test of your empirical formula knowledge, which you've done at GCSE, and you must have done it earlier in this year as well, year 1. Okay, so let's do this. So the way I do it is I draw a table, right, of the number of elements that are there. So there's carbon there and hydrogen there, and not forgetting, this is a mixture of chlorinated compounds. Okay, so it must have chlorine there as well. All right, so now I'm just going to put in the percentage. So 24.6% of carbon, hydrogen is 2.56, and therefore I need to work out how much must the chlorine be in there. And of course the chlorine is not either the 37 or the 35, it's the average chlorine, the relative atomic mass, which is from the periodic table, which is 35.5. So that's the mass. Okay, I'm putting it there so I remember. Okay, so anyway, so chlorine here. Now what percentage? Well, if it's a percentage and you got this as this percentage of carbon, this percentage of hydrogen, then it's a simple mass to work out. 100 minus all of that. So the percentage of chlorine would be 72.8%. So, and the next thing is usual thing. Usually if you're given grams, you can use the grams as well. Percentage is not a problem. It's a percentage. So what the next thing you do is, in a table, you divide each of them by the relative atomic mass of the element you're talking about. So 24.6 divided by 12, and then 2.56 divided by 1, because the atomic mass of hydrogen is 1. And of course, and this is why I wrote down 35.5, because I didn't want to start dividing by 35 or 37, right? It's the average. And of course, what you end up getting is, work it out on the calculator, you end up getting 2.5. And the next step, you divide by the lowest number, so divide by RAM divided by lowest number out of all of these. Okay, so I'm going to divide each of them by 2.05, because that's the lowest number. That gives you 1, that gives you 1, and that gives you 1.25. Now at this point, what some students do is they round it down, of course, because 2 is less than 5, so therefore they're going to say, oh, this is equivalent to 1. No, compared to 1, 0.25 is a quarter compared to that 1. So it's a big difference, So I need to now find out, how do I make this a whole number? You can work it out, trial and error, but I can see that if this is a quarter, then that means if I multiply that by 4, I should get a whole number. But you can try it, you can trial it. So I'm going to multiply this by 4 to give me 5. So 4 times 1.25 is 5. Okay, and of course this, multiply that, I've got to multiply these as well by the same number. So that gives me 4, that gives me 4. So that means the empirical formula of this compound is C4, H5, and Cl4. But remember, this is not the answer to the question. Calculate the molecular formula. The question says molecular formula, not the empirical formula. So now I need to work out the molecular formula. And I'm thinking, well, hold on. They're not giving me MR of this molecule. How am I going to work out the molecular formula? Because that's what you usually are given. MR, the total MR, the final MR. And then you can say, all right, well, I can work this out. But remember, they've told you, it's a chlorinated octane compound, because they took the isooctane and they chlorinated it. So it does have 8 carbons. So that means what you got to do is you got to multiply this in such a way to actually give you 8 carbons. So what I've got to do is I've got to say, okay, well, if I multiply that by 2, that'll give me 8 carbons. But then I've got to multiply that by 2 as well, and that by 2 as well. So it'll be C8, H10, Cl8. And that is your molecular formula. Okay, so the marks you're going to get for this, I mean, it's worth 3 marks. So you're going to have to, obviously you'll get a mark for your final answer, obviously, and then of course you're probably going to get a mark for this, for either doing that to get you 1.25 to 1, and then you're probably going to get a mark to give you a whole ratio as well. Okay, and then of course the final mark is going to be that, so that's 3 marks. Okay, so this 12-mark multi-part question is almost all organic, okay, with aspects of physical thrown in. Okay, it's one of the techniques that the examiners use to sort of quickly assess your, a wide variety of knowledge. Okay, and again, practice these questions. Yeah, once you practice them, you're not going to find them difficult, I don't think. Anyway, so I hope you found that useful. And if if you think there's a better way, of doing this question, especially these isomers, finding out the number of isomers given a molecule. Yeah, I mean, I literally do trial and error. If you think there's a better way of actually working out, these isomers, if they give you a sort of a structure and they say, right, how many possible isomers are there? Is there a formula? I've not come across it yet, but is there a formula? Yeah, but if there is, please let me know in the comments below. I would love to know, because I've not been able to find a quick way of working out the number of isomers if they give you a structure. Yeah, apart from just trial and error. Okay, please subscribe. Okay, and like the video and share it. And I'll see you next Wednesday.